Hello, my name is Luis, and in this video I'm going to show you the functionality of my resolution for the project TicTacToe from the Introduction to Artificial Intelligence with Python. So by using Minimax, implement an artificial intelligence to play TicTacToe optimally. So here we go. The specifications. From the provided code, we must modify a few functions. So the first of all, the player function, and the answer was by counting the number of empty spaces we can know which player's turn is. So for example, if we count in this case 9 empty spaces, it will be an odd number, so that means it is X turn. But on the other hand, 8 empty players, which is an even number, will means odd turn. The next function is actions, so we must return the possible actions on the current board. So what I did is, again, counting the empty spaces and add it to the set. So in this case we have only 3 possible actions. The next one is the result function, which takes a board as an input and execute the action, creating a copy of the original board, and then executing the action by using the player function. Then we have the winner function, so we must identify all the possible states on the board. So we have 3 victory conditions: diagonal, vertical, horizontal. We also have a possible tie, and the game is in progress. So to identify the victory state, we created a new function to return true wherever the victory is achieved. Otherwise, it will return false. And to identify the player who won, who lost, well, we use the player function, which returns the next player's turn, and we just take the opposite of that. But we need to identify if it is a tie or is still in progress. So to do that, we use the terminal function, and we check as well if there is victory, there is an empty cell, which means the game is still in progress. Otherwise, the game finished on tie. So as you can see, if the game is terminal, well, that means somebody won. If it's not terminal, so that means there is still some empty spaces. And see, if nobody won and the board is filled, well, the game is finished as tied. And as you can see, it's just the same to get the winner. So now let's talk about the utility function. So we have a board as an input, and we return the utility of that board after we know that it's already finished. So for the first one, we know that the utility for the first board, which X is the winner, we have an utility of 1. For the tie is an utility of 0, and for the case in the all wins, well, there is a utility of -1. And why? Well, because we are using the Minimax algorithm, and I'm not gonna dive into the details about Minimax, and I'm gonna let you hear some links about the reference I use. But the main things you need to know is that Minimax is a recursive algorithm, so this means it calls itself until it reaches the final state for each action. And this is an algorithm designed for at least 2-player game. So we have player X and player O. The player X will try to maximize the score, since the player O will try to minimize the score. So that's why we have the utility of the terminal state of the board. And so let's dive a little bit on the Minimax function. So we have that it returns the optimal action for the specific board. And to do that, we consider all the other functions that we already did. So first of all, we check if the board is on a terminal state. because if it is in a terminal state, there is no possible action, so the game is done. Then we check if the current player is trying to maximize or trying to minimize, and we set the initial value of the best score to -infinite if we are trying to maximize, or for infinite if we are trying to minimize. Why? Well, because if we are trying to maximizing, we start from the lowest possible, which is -infinite, and then any other utility from the utility function that we get will be better and will be higher than -infinite. So in that way, we can update the score and get the best score, the maximum one. On the other hand, if we start from infinite, we are trying to minimize it, so any other value will be less than infinite. So that's why we have the evaluate function, which is another one that I create, and it returns the optimal score. In that way, we can update and get the optimal action. So as you can see, we have the player X is the maximizer player, and the player O is the minimizing one. So in the evaluate function, which is the recursive algorithm, will call itself, and it's almost the same, but in this case, this returns, instead of the optimal action, it returns the utility. In that way, we can update the score. So just to clarify a little bit more, we have the loop, the complete loop here. So we start from the terminal board, we check if the game has finished. If it's not, well, we keep evaluating. So we check wherever the player is, so it's trying to maximize or it's trying to minimize. Then we get all the actions, all the possible actions from the given board. Then we check the result of executing every action, and we evaluate that action. This means that we will go through this loop until get a terminal board, which means that we get the utility of that board. So for instance, we have this case. We start from this almost finished board, and imagine that we are trying to minimize. So we think about, what possible actions do I have? So I can go left to the bottom or right at the middle. And if I go left to the bottom, I know that the utility will be 0. But on the other hand, the utility for the board, if I go right middle, will be 1. So if I'm trying to minimize, I will prefer choosing the left option rather than the right option, because 0 is less than 1. And this is how it works. I'm gonna show you the algorithm working. I mean, I will lose against the artificial intelligence right now.